Hello, my name is Ben Jeffries, and this is my final year project presentation. So this whole project started with a question, and the question was, how can you enhance a performance using extended reality? Now, this is not a new concept to any kind of performance industry. Motion capture and extended reality have been used in performances on a 2D screen and in a 3D environment. But I wanted to explore how can you enhance that and how can you use it again in real time. So I started off by looking at hardware and what kind of hardware could be most suitable for this kind of task. There were quite a few things that I could have used. I could have used a Meta Quest 3. I could have gone very expensive and used a Vario headset or something like an HTC Vive. I decided on two solutions in the end, one based around pre-recorded motion capture and another based around real-time motion capture. I used the Apple Vision Pro and I used a Meta Quest 3. So we'll start with the pre-recorded motion capture first in the Apple Vision Pro. Now, the original intention for this project was to explore how to get real-time motion capture into augmented reality. And the reason I chose augmented reality over virtual reality is all because you don't want to take the audience out of the room they are in. You don't want to disassociate the audience with their natural environment. You want to add to it. And through research, I found that that was a more mass marketly feasible solution over a virtual reality solution. That also means that I don't have to just be limited by a headset. This could be used on mobile devices, and it could be used in other kind of glasses going forward. We don't know that headsets will take off yet, so I wanted to make my product malleable to that industry. So the first product I decided to work with was the Apple Vision Pro, and the reason I decided to use this headset was for two reasons. One, because of the level of the pass-through of the headset. It is the industry-leading pass-through right now, in my opinion. After testing multiple headsets, I found that the quality of the cameras in the Vision Pro provided the best experience for an augmented reality headset. And the second reason why is because of the interaction system that Apple has developed for this headset. You don't have to use controllers. It uses eye tracking. You can look at an object and just pinch with your fingers to interact with things. And I have built my project around that interaction system. So we have a Vision Pro here. I will pop this on. So we could take any basic FBX model and we could place it in augmented reality. Now, another reason I chose the Vision Pro was for the level of the plane detection. There is very limited, or there's very little movement in the Vision Pro's plane detection, and that is quite rare for a headset. This is constantly being developed, constantly being improved, and maybe other companies may overtake Apple on this. But at the moment, as of making this project, the Vision Pro has the most stable plane detection that I have seen, and therefore it is another reason to use it. So we've seen a static object in the Vision Pro. Now, if we move over to more of a performance element, we can then take pre-recorded motion capture and place it in our environment. Now, the use case for this are quite a few. What we could see this for is for, of course, pre-recorded performances. If we look at the theatre industry, for example, we could take a performance that someone has done and then place it into the living room of the audience member. And so they get the experience of not only just watching it on a 2D screen, but as is intended by the director's vision to see it in their space. And that is why I think the Vision Pro is the one to develop for right now, because they are targeting mass market, and they also understand that augmented reality and placing objects in the room and making that believable is the key to making this sellable. Now, one thing that is to be of note, and that is to sell the realism in the room. Shadows are a very important thing. Everything emits a shadow, and if you want to sell the aspect of something being in the room with you, you want to use that shadow, and that is what's being seen here. We are projecting a shadow onto the detected plane. So this was pre-recorded motion capture from Marta. This was recorded a few months ago. It's being cleaned up, and it is now placed into augmented reality using Unity. Now, I also developed a system of interactions here. We have a rotate, we have a move, and we have a reset as well, so that we can place it in the environment again. And all this has been developed from scratch. Okay, so that is pre-recorded motion capture. So the obvious step after that is real-time motion capture. And that's where I introduce my friend James. James here will help me demonstrate real-time motion capture into augmented reality. So this can be done on a Vision Pro. So if you'd like to get real-time motion capture into Vision Pro, it will require development of an API. Given more time, that would be something I'd want to explore, but given the time constraints, then I would prefer to just get something running in a MetaQuest 3, which does still provide a great pass-through, just not as good as the Vision Pro. So I'm going to pop this on. So now we are going to demonstrate real-time motion capture in a MetaQuest 3. Now the reason I chose a MetaQuest 3 was for the fact of its native integration within graphics engines like Unreal Engine. When thinking about a motion capture studio, which is what this real-time motion capture is intended for, we want to specifically look at what the industry uses currently. That industry pipeline at the moment usually consists of Vicon Shogun into Autodesk Motion Builder, Autodesk Motion Builder to Unreal Engine. And so if I could develop a tool that could be integrated into Unreal Engine, then that could provide a good solution for industry to use. And that is the intention of the real-time motion capture element of this project, is to be picked up within the motion capture industry. So we can see James here. We can see the character on top of James. James, could you just give me a wave for me? Perfect. Okay, so we can see that the retarget into Unreal Engine is not 100% perfect, and that is motion capture. Motion capture is very, very accurate. It's not 100% accurate though. James, could you pick up the football for me? So as the football enters the volume, we should see, could you just give it a move about? There we go. So as the football starts tracking, we can see it being picked up, and we can see a pre-visualization in a 3D environment. Now, a lot of reasons, a lot of benefits to use this over pre-visualization in a 2D environment. Motion capture is not only used for 2D solutions. Yes, it is used in movies. Yes, it is used in games, etc. However, there are scenarios where it is not used on a 2D environment and is intended for a 3D environment. If we think live theater, if we think real-time performances, the director intends the audience to see it live, to see it in a 3D environment. So they will want to see the end product or the mocap data in a 3D environment over pre-visualizing it in a 2D environment. And that's what we have here. So James, if you could just give me a few bounces of the ball for me. So if I were directing this piece, we could have a look at the motion capture data in real time. We could see the retarget. We can see that that it is very accurate. There is a slight difference, but I think that is looking good. James, could you give me some finger movements, please? So you can see that we're using a 3-finger setup, so it is not exactly going to replicate all of his finger movements. And that is a choice we made when markering James up. However, I think that data is looking good. If I were a director, I'd be very happy with it. Okay, yeah, let's do some kicky uppies. Let's have a bit of fun with this. Go on. Nice, good job, good job. All right. So yes, there are many use cases for this. Like I said, this can be used in the motion capture industry. As it is currently, it is a proof of concept. This could be refined. I think the calibration system could be refined as well. Current calibration system I've got working is to place the controller on the floor to work out the height, and then it's using the headset's position to do X and Z directions. This could also eventually be used for the end user, an end user audience. If you want to live stream a performance of a play, this same pipeline could be used to do that. Okay, now I believe that's everything I've got to show you. I'm now going to cut to the live Q&A that was on the day, so you can hear some of the responses. Thank you very much for watching. So what I have developed is, the system from between Shogun to Motion Builder to Unreal is the industry standard. So that's just been utilized. What's been developed is the system to get that character from an Unreal scene into augmented reality, and to get it calibrated in the scene between the real life and the virtual character. That process includes a lot of tracking involving the headset and the controller. I'm taking the X and Z position from the headset, and I'm taking the Y position from a controller on the floor. That means that a person can stay in the headset, calibrate it in the headset, and then they can just keep going on there. So you don't have to take it off, put it on the floor, put it back on, all that stuff. In terms of the Vision Pro stuff, there's no lie, obviously, I learned a lot of the development from you guys, from Natural Motion. I've then taken that and kind of added onto it a little bit. So instead of just models there, we've now got motion capture data. But yes, the scripts were made from scratch again. So yes, the Vision Pro stuff is from scratch. The Unreal motion capture from Unreal to AR is, yes, again, from scratch. To get the character into Unreal is industry pipeline. Okay, go for it.
What, if any, during development, would you say was the biggest problem you came across whilst making this pipeline, developing it, and how did you solve it?
Great question. I think the hardest thing when developing this is with the compatibility with the Vision Pro. It's no secret that there are a lot of hurdles in place to develop for that headset, and there are a lot of things that you must use to be able to work on it, and that limits the scope massively. So being able to make the best product in the scope that I have was quite a bit of a challenge. Go on.
Have you tried to have more than one headset at a time?
No. So you can run it independently and link it to the same live link session, it's called, the same Unreal Engine. The same Motion Builder session in different Unreal Engine editors. To get it into the same Unreal editor, multiple headsets would require a multiplayer session and a multiplayer server. That would take quite a lot of learning. So it could be done, yes, with a lot more development on it. Yeah. Good. Any other questions?
So many possibilities here. It's
Yes.
really exciting. So within the scope of this project, what does success look like for you at the end of this bound project?
I would say success at the end of this project for me is interest from industry. So if the industry would be interested in taking it on board, I would consider that a success. Okay. Yes. Any other questions?
What would you have done differently?
Remember, I did the
I think I would have put. I think I would have put a little bit more time into refining calibration for real time use. Obviously, the calibration setup it's an accurate representation of motion capture, but it's very raw. It's not entirely 100% accurate. It never will be, but I think it could get a couple of notches closer to being 100% accurate. So yeah. Any other? Go on.
So what are the main compromises you have to take to go real time as opposed to pre-recorded?
So with pre-recorded, well, in short, it's a completely different setup to do. The longer answer is for pre-recorded motion capture, you can bring it in as an FBX file, as a model file, and that will then you can then play an animation through the model file. For real-time stuff, you need to have a direct connection, a direct API with the host server. So we're then talking networking issues. We're talking input lag or server lag. It would still use an FBX, it would still use a model file, but it would have to be updated every tick, basically. And to do that would require a whole different animation file, animation system.
And when we saw the performance today, what sort of latency are we getting between?
We are getting, latency-wise, what's standard for this? What's standard for latency here?
From where to where?
From
you get a bit of latency dip, but it's minuscule from Shogun to Motion Builder,
Yeah.
and then a little bit from Shogun to Unreal as well.
Yeah.
Milliseconds?
I think, yeah. It's the answer is within reason negligible. Yeah.
You can try doing a test of that if you want. So if you look
Yeah.
at have we got Shogun on this screen here?
Yes, should.
Yeah.
Yes, on this screen.
It's going to be hard to see.
It
but
will.
If you look really quickly, if you look at the cloud, if you were to cloud, and then you see on the different machines, it should display at ever so slightly different, but probably at the exact same time. It's going to be very
Yeah.
noticeable.
Some of the biggest delays we have in here are the LED.
Correct,
The
yeah.
TVs.
The biggest delay is to the screen.
Yeah, absolutely. Yeah. So to headset, yeah, it's we're talking milliseconds.
Have you got it running at 90, Ben?
Yes,
Yeah.
90
So
frames.
a
I see another
90th, a
clap.
90th of a second is your refresh time. Is your
There we go.
refresh time.
Yeah. Okay. Thank you. Magic.
Will we be the benefit of using a headset instead of a microphone or VCAM?
Instead of the VCAM.
Yes.
So when you're working, when you're producing motion capture content, it's not just for a 2D screen. It can be for the rise of VR games at the moment. Use motion capture that's not intended to be viewed on a 2D screen. Things in theatre as well. Live performances that could use motion capture. So that kind of stuff you'd want to pre-visualize in a 3D environment over a 2D environment, because there is a difference. There is a big difference when you're watching that footage back, and you want to have it from an audience's perspective to see what they could see. So in a 3D environment, yeah, it could make a big difference over a 2D screen.
What kind of do you imagine adding any kind of interactive tools or tools, I suppose, with regards to using the VR headset and so forth?
I'd love to think so. So much like the Vision Pro project, where you've got the rotate variable and the movement reset lock, if you could, we could definitely put that into the live one, definitely. And to be honest, if I were to go on with this, I'd want to do that. The difference with this project is that when working in a motion capture studio, you're working in a team. So you would have someone in the gantry operating this system while the director has the headset on, and they want a lot of that done for them. So they would want all the fine controls to be handled not only by themselves but by someone else, and I prioritise someone else before themselves.
But what kind of tools do the director use?
What, apart from move, rotate, that kind of thing?
I feel like there could be lots of different applications for it, so you could maybe have different versions, different.
Yeah, possibly. I mean, if you want to go really crazy and try and mess with we're running an Unreal Engine, why not some particle physics and like a OSC board, an AR OSC board that you can trigger a fireworks explosion or something in the scene. You can do that.
This sort of thing makes me think of like the early days of motion pictures where basically they stuck a camera up, the camera never moved because the very half the time it was stuck close to the floor, and then you basically film the stage. And somewhere along you're going to get somebody doing stuff like that first shot at 60k where they zoom up and through the
Yeah.
you know, and you start doing all clever tricks. Except Altamont had to do that with tricks. He actually had to think about the part. Now you can do it CGI. And with this, you could actually have a director beginning to move camera angles, those sorts of things.
Absolutely. Yeah. Absolutely.
Would it be beneficial for the actor to wear the headset so to see your own motion,
I
but
think-
in a virtual environment you're supposed to involve instead of
Yeah.
seeing an empty room?
Yeah, and that has been done before, so that currently exists. And I think it's incredible. And I think it's very beneficial. If I could get the calibration and the tracking rock solid enough, it might work. The other problem that we have is that from retarget, from the raw data to the end product, there is a bit of difference. There is a retarget, so it might be a bit uncanny valley. Because I mean, if you look at your arm, the retarget won't be exactly where your arm is. It will be very accurate to where it is, but it won't be exactly where it is.
Because it might be obvious if you try to be a human, you look at your own fingers, you hold the so. But if we're supposed to act as being a bear or robot, and we're
Absolutely.
supposed to have other parts,
Absolutely.
seeing that extension of you as another thing in an environment might help the acting also.
Absolutely. Yeah, no, I completely agree with that. Definitely. Yeah. Peter?
Does the calibration drift over time?
Yes. So because it's not by a lot, the Quest 3 is very good at that. That's hardware dependent. The best one for that has inside-out tracking, to be honest, is the Vision Pro. If you want the best thing for combating drift, you'd want something that utilizes the lighthouses here. That's not inside-out tracking. That is using the lighthouse to figure out where it is in the room. A headset like this does not use lighthouses. It uses inside-out tracking, and the benefit of that is that you don't need to set up lighthouses, and that's a massive benefit.
I'm not suggesting this should be part of your project.
Yep.
Perhaps for a future project. Is it possible to calibrate on the fly? So as you go, a little bit like GPS calibrates my sat nav on the fly.
Yeah. So the system I've developed, you can stand on Origin, you can stand on the dead center of the stage and calibrate it whenever, mid-performance if you'd like. To calibrate it on the fly, are you talking so I can stand wherever I like and then calibrate it as
Well,
it
not
goes?
necessarily, but if you pass over a point or you look at a point, being able to use that as a way of.
Absolutely. Yeah. If you use image reference, that's very possible. Yes. Something to look into, definitely. Yeah. Go on.
Will the drift be reduced if you had a different flow? Because
Yes. So there are many different things that could impact drift. One of them definitely being the floor. So if you take the floor out there, for example, it's all nice and shiny, and the tracking on that is rough. Another thing that could, so stuff like so when you're calibrating, that will make an impact. Anything the headset sees will impact it basically when it comes to calibrating.
Can I ask a motion capture question? Nothing to do with the presentation. What's the thing in front of Sophie's face?
Great question. So we were experimenting with trying to get facial capture working today. Unfortunately, we ran out of time. So it was an experiment that we weren't able to do. But it was a last minute kind of stretch goal. Let's see what we can do. But yeah, we didn't have time for it. Yeah. Yeah.
You mentioned that an ideal goal for you for this product would be that it would be picked up by industry, would be an ideal. If it weren't, we were going in the far stretched future of like a perfect scenario for you, what would you hope this could lead to in the future? Not just being picked up in industry, like what examples would you hope industry could use for this if they were to pick it up? Like would you hope for them to be able to use it for certain games or certain like massive music festivals, like instead of having to fly a performer out to Vegas, they'd be able to do it in a small studio in their hometown in England or something instead?
Yeah.
Or
And that system already exists, and that is being used currently. What I'd love to see from this project is it to be integrated into a standard pipeline for studios to use, especially the real-time stuff. The stuff in the Vision Pro, I'd love to see developed into an app that can be used by people at their own homes to view live performance. That's the end goal.